Now, for years, I think when we think about IoT, Wi-Fi is sort of the last low-power wireless technology we'd consider putting into a battery-powered IoT application. It's sort of always been considered to be a poor combination, and all the other wireless technologies are there for the when you really need to go to the lowest power. But I understand the Wi-Fi specification is changing. What's going on in Wi-Fi?
Yeah, that's a very good question, Stuart, because certainly if you really look at the Wi-Fi, it started off with a technology meant for laptops, cell phones, right, which are not as power hungry kind of devices. And what has been happening traditionally is people are using the Wi-Fi, which we call as traditional Wi-Fi, for IoT Wi-Fi applications, which is not the correct usage. IoT Wi-Fi is completely different. You need to redesign it for IoT devices, which are power sensitive devices. They could be small form factor kind of devices. They need lower cost. They need to operate with microcontrollers, which are extremely small. So in fact, if you look at the parameters for IoT devices, they are completely different from traditional kind of devices. So what has happened is if you start using the traditional Wi-Fi, it's not going to work. So now there's a whole class of new Wi-Fi solutions which is coming up, which is really meant for IoT devices. And this is where, in fact, our first generation Wi-Fi, which is RS9116, which is Wi-Fi 4, is extremely beneficial as well because we have redesigned it completely grounds up for low power IoT devices. Because when you're talking about power consumption, you really need to look at it from a system point of view. From a device point of view, you really need to wake up, you need to transmit, then you need to go back to sleep as soon as possible to reduce the energy consumption of the whole system. So this is something which is very important. So for our Wi-Fi 4 devices, which is RS9116, we have done that extremely well, and now we are able to bring the battery life down significantly, where we have provided, in fact, I would say even more than 2x improvement in some of the applications like smart locks. But in addition to that, what has also happened now is Wi-Fi 6 has come. And Wi-Fi 6 has introduced additional parameters which enable low power IoT devices even further. So there are some technologies called TWT, which is target wake up time, and there's OFDMA, which enables a better use of spectrum. Combining these two technologies, you can further reduce the energy consumption of an IoT device. So combination, I would say, of system level approach
Yeah.
as well as technology itself can lead to significant reduction in power.
Now, obviously, when we look at all the different types of Wi-Fi technologies, it's a little bit become a little bit confused, isn't it, over the years? Because we have the IEEE standards for Wi-Fi, but we also have some sort of like marketing terminology. So Wi-Fi 4 is 802.11n, which is a 2.4 and 5 gigahertz technology. I mean, for an IoT application, one of the concerns is obviously as the transceiver and transmission frequencies increase, the power required and also the range, power required increases, the range reduces. Do IoT devices have to support both 2.4 and 5 gigahertz?
Sure, this is another very interesting question because if you really look at it, 2.4 gigahertz is certainly much better as compared to 5 gigahertz, as you just indicated, right? 2.4 gigahertz can give you much longer range. It has much better performance around the corner, specifically when you're inside a house. Corners are there, right? So where the performance can go down if you're talking about 5 gigahertz. Then it is lower in power, it is lower in cost. But what started happening was specifically in home environment, a lot of new devices started coming up, right? So now if I look at a smart home, you may have 50 to 70 or even increasing to 100 plus devices in a home. And because of the number of coexisting devices and all of them operating in the same 2.4 gigahertz spectrum, the spectrum was becoming very crowded. And this is where Wi-Fi 4 started creating problems. And people thought, okay, maybe we really need to look at now 5 gigahertz because 2.4 gigahertz, you cannot have too many devices operating at the same time. And this is where, in fact, Wi-Fi 6 now steps up, right? So Wi-Fi 6 has introduced technology called OFDMA, which enables a lot more devices to coexist in a 2.4 gigahertz environment. Now, from really, if I look at it from an IoT device point of view, there is no need to use 5 gigahertz anymore now because the issue which was associated with 2.4 gigahertz has gone away with Wi-Fi 6. Having said that, there will always be some applications which will need 5 gigahertz. So because 5 gigahertz certainly provides higher throughputs. And there are some environments where 5 gigahertz is mandatory when you're talking about, let's say, maybe a medical environment, some industrial environment. you may certainly need 5 gigahertz, but there are a lot of other devices where 5 gigahertz is no longer really required.
Super. So, as we said, so the marketing terminology, Wi-Fi 6 is related to the standard 802.11ax, and this covers also both the 2.4 and 5 gigahertz frequency bands. Now, most of the people's expectation as consumers is that the next generation of Wi-Fi is always going to be more connectivity, better support for a large number of devices, and that gives us the ability to stream to our TVs, stream to lots of laptops and handsets and tablets, and handsets and things like that in the home. But there's also been quite a lot of work done to support the challenges of IoT devices, the fact that they really need to be off quite a lot in order to save power, or at least have some sort of sleep capability and not be active all the time, which is something that's part of the Wi-Fi specification normally for normal devices. So what are the new mechanisms that have been added into Wi-Fi 6 that are really good for low power IoT?
Sure, certainly. So if you look at power consumption again, right? So traditionally what people were doing was to reduce the power consumption. They were really putting the devices completely into shutdown mode, right? That's the best way to do it. But that's not effective, because then you need to wake up, then you need to connect to the network, right? So that takes time, absolutely, right? So now, then there was this whole mechanism which is present even in Wi-Fi 4, where you can really sleep for a small duration, and you can control that based on either DPIM or listen interval. So that's something that you can do. So where the device still kind of, this is called as an IEEE power save mechanism, where the device still kind of stays connected, but it goes to sleep and wakes up at predefined times and sees if there's an activity for a particular node. If there is activity, it's going to go into full-blown wake-up mode and complete the activity and then go back into sleep. Okay, so this is a device, this is a mechanism which has been used by, in fact, Wi-Fi 4, and we can quite effectively use it for a lot of other devices. A lot of things like, for example, smart lock or sensor kind of devices as well. Beyond that, now there are some additional mechanisms, which is a TWT mechanism, which is target wake-up time, which is a very interesting mechanism where now the sleep time of a device can increase significantly. It's really the device communicates with the access point on how long does it want to sleep. Because in a sensor, for example, some sensors, you may say, I want to sleep for, let's say, a few minutes, and then I want to wake up. So that is a pre-negotiated time with an access point. Based on that, the energy consumption of those devices can reduce significantly. Because instead of now sleeping for a few microseconds or milliseconds, now you can sleep up for minutes and even more than that, right? So this is something which is significant in Wi-Fi 6, which is different from Wi-Fi 4. In addition to that, what is also happening is the efficient use of spectrum, which is OFDM-A, right? So, and the problem that happens with Wi-Fi 4, it uses OFDM, for example, right? In OFDM, the efficiency of the spectrum usage is not there. Because of that, there's a lot of collision which happens. So people have to retransmit. They have to really wait for their turn to transmit. With OFDM-A, you can transmit. In fact, and the collisions are quite rare as well. And because of that, the overall power consumption of the device also reduces. So these are, I would say, two additional mechanisms which have been added in on top of DTIM, UAPSD, WMM, some of those things which were already present in Wi-Fi 4 as well.
Right. Okay. So that's one of the other things I was going to mention, because I don't know if it's sort of as clear maybe what mechanisms already are there. So there's WMM, which is the Wi-Fi multimedia power source. That is I've understood at least is a sort of a buffering mechanism, which allows packets to be stored until the node that it's targeting or prepared for is awake. Then you have delivery traffic indication messages, DTIM, which is sort of the router actually provides a beacon, doesn't it, regularly, and that helps everything to make sure that you're still connected to your router. And then we have the unscheduled auto power save delivery, the UAPSD. Not difficult to say at all. And that's where the client sleeps, where there's no data to transmit, and just wakes to transmit its packet and then collect anything that may have been prepared for it in the meantime. So,
Exactly. WMM and UAPSD are kind of inherent mechanisms which the tools always use. But on top of that, DTIM is one mechanism which is a controllable mechanism which is used for sensors a lot. You can play around with DTIM. You can say, I want a DTIM interval of 1 or DTIM of 10. 1 means really you're doing 1 millisecond, and 10 means 10 milliseconds, right? So you're sleeping for that much amount of time, and then you wake up and see if there's a particular traffic out, for a particular node. So these are different mechanisms which are available in the prior standards as well. So Wi-Fi 6 has introduced TWT and ODMA, which further improves the power situation of a particular device.
now, one of the critical things when you're developing these low power applications is obviously trying to, microcontrollers are sort of one area where it is you've got to make sort of choices as to what do I turn off, what do I turn on, how much do I use sort of static, active power, and the low power capabilities of a microcontroller. When I've got Wi-Fi and all those, these capabilities within the specification, how much choice is available to me as a developer to select and turn on and turn off and tune these low power capabilities over the Wi-Fi link?
Sure. So again, if I look at it, it's all about the use case of a particular Wi-Fi device, right? So use case could be as simple as a temperature sensor, or it could be, for example, you're talking about maybe a security camera, or you're talking about, let's say, a video doorbell. So every use case requirement tends to be different. If I'm doing, for example, let's say a wireless sensor, a temperature sensor, then in reality, a lot of it can be completely shut down. So you can keep on collecting the data on the temperature sensor. And depending upon how often you want to refresh, you can go into an active mode and transmit the information and go back into sleep mode, right? So that's a completely different use case. Now, if you're talking about, let's say, a security camera, really maybe you want to wake up as soon as you detect a motion. So in that particular case, you can have a sensor which is detecting the motion. As soon as that motion is detected, you can go back into complete wake up mode and start transmitting as well. So similarly, now if you're talking about video doorbell, it's more latency driven. So as soon as you press a particular button, you want to make sure that that button gets registered and the video transmission starts happening as well. So depending on a particular use case of an IoT device, the user has a mechanism of completely shutting down, in fact, maybe a microcontroller with a very small microcontroller, because there is now a concept of big little. So you can have a little microcontroller which can stay awake, which is dealing with all of these sensors and all, and the big microcontroller can be turned on as and when required, right? So there are mechanisms which you can use depending upon the use case. So you can turn on and off the microcontroller, different parts of the microcontroller. Similarly, you can turn on and off the wireless side as well. So depending upon the use case, the user has all the flexibility, but it's, I would say, completely up to the user based on the use case to decide what can be turned on, what can be turned off. But the bells and whistles are available on the wireless side as well as the microcontroller side.
Now, when these Wi-Fi 6 based nodes actually go and use these mechanisms, what happens to the established connection when they wake up? Is there anything that needs to be done, like acquiring a new IP address or authenticating a secure link, or can they make use of what was already established when they first initially connected?
Yeah, so that's one of the unique things, in fact, about the IEEE power save mechanism. Even in Wi-Fi 4, when you wake up, the connection is already there. So you are not really putting it into complete sleep mode. So you're maintaining some status which is related to the connection, right? And again, going back to my previous response on the use case, there is a possibility where you can say, I want to completely shut it down, because that always will reduce your power consumption to the bare minimum. But most of the cases, you don't have to. You can always keep the connectivity on and just go live as and when required, depending upon the use case of a particular device. So these mechanisms, whatever are there right now, for example, the TWT that I talked about, DTIM I talked about, all of these mechanisms are available. In fact, even in a completely connected state. So you don't lose the connection with the access point. You don't lose the IP address that has been assigned.
Of course, and if you were taking the choice to completely close the connection and re-authenticate on wake up, that would actually require more power, wouldn't it? Because you'd have to go through a quite long process of communication to establish the link and acquire the IP address. So it's sort of a balance then, isn't it? Of
Absolutely. But again, if let's say there's a device which is going to do that once in 24 hours, versus a device which has to do it every few milliseconds. Again, it's completely, I would say, use case dependent. If it's a sensor and sensor has to transmit once a day, it may be okay to completely shut it down, and when it wakes up, it connects. So it's really about looking at the complete data profile, understanding what is the energy consumption, where, and based on that, optimization has to be done in terms of which particular mechanism should be used to optimize the energy consumption of the complete system, right? So that's really where people have to focus on.
Yeah. Now, homes, offices, and sort of industrial sites are notoriously busy in these 2.4 and 5 gigahertz spectrums. And although Wi-Fi 6 is there and offers all these power saving capabilities for an IoT sensor, the challenge is, isn't it, that there's still lots of technology based on Wi-Fi 4 using maybe the transmission technology, and that will cause sort of interference on the channels and the communications in those bandwidths. So, what impact does that's something you can't plan for as an engineer. You can only plan for all the capabilities and the options that you have in the software and the specifications. So what impact does interference have on battery life and power consumption? And is there anything a designer can sort of do in order to improve things?
Absolutely. In fact, interference has a significant impact on battery life as well, right? Because if, let's say, I want to transmit the data and suddenly I run into collision in the air, then in that case, I may have to retransmit the data. Uh, so that is something which is going to certainly increase the energy consumption of the device, right? So again, going back to use case, when you're trying to look at a particular use case, you have to take interference also into account when you're trying to decide for a particular system. That's an important part because, and it's going to keep increasing. So Wi-Fi 6 certainly has this capability which reduces interference because it has more efficient use of the spectrum. So you have to look at that as well. So if, let's say, you want to operate in 2.4 gigahertz, you have a large number of devices which are going to operate at the same time, and you have, let's say, not just Wi-Fi, you could have BLE and other 2.4 gigahertz devices operating there as well. So from a use case point of view, the decision has to be made whether it makes sense to maybe look at Wi-Fi 4, whether it makes sense to look at Wi-Fi 6. That's an important decision to be made as well. But moving forward, I would certainly say if from a power point of view, Wi-Fi 6 certainly is going to be a lot more beneficial, and it has a lot more capabilities. And then people have to look at the interference and see how it can be minimized as well, right? So which channels to operate in, how do you switch channels? All of that is also important kind of decision-making factor when you're trying to decide how to operate in Wi-Fi, either 2.4 or 5 gigahertz spectrums. But that, again, I would say that is all, I will put that as part of the use case, because if I'm trying to deploy in a home, that's a whole different use case versus if I'm trying to deploy in an industrial environment. If, let's say, it's very critical that I need to react in a microsecond, in that case, the design is going to be completely different as opposed to a reaction time of a millisecond or a second, right? So the use cases define which spectrum to use, how to use it, and when to use it.
Now, one of the challenges embedded developers and the rest of the team have when it comes to sort of these applications where low power consumption is the critical element is, sort of comparing all the options that are available on the market. There's obviously part of it has to be a microcontroller. The other part is the radio transceiver. And then we're talking about measuring often microamps, or jumps between microamps and milliamps, which is a difficult measurement to make with any sort of power tool. Normally, you need some sort of power analyzer dedicated to that sort of huge jump in current consumption. So how and then of course the only other option that you have before you get started is just the data sheets where you can you've got some numbers on a piece of paper, and sometimes they're a bit on the conservative side. So how do you help customers, design engineers evaluate sort of the options when it comes to microcontrollers and radio transceivers, and do you have any sort of power measurement tools that you have at Silicon Labs for customers to use?
Exactly. So, of course, as you indicated, right, the most crudest part is, of course, the data sheet. You can start looking at the data sheet, but that's very, very crude estimation, because when you're talking about your actual use case, the complete data profile, the use model dictates what the final energy consumption is going to be. The second level is really power estimation tools, which could be a simple Excel sheet where you say, okay, my device is going to stay on for X amount of time. And then after that, I'm going to transmit so many bytes or kilobytes or megabytes. And then I'm going to go back into sleep. And that is some mechanism that we provide as well, a simple kind of an Excel-based calculation. That again is the second level. The third level is really when you get into the actual design, you need to really measure at a very accurate level on how much energy consumption is there. So we have mechanisms in our kit. We have recently, in fact, released a completely new evaluation kit as well, which has a capability of automatic energy measurement capabilities there, which can enable the designers to do the measurement live when they are doing the actual code development of the microcontroller as well, right? So these are various tools available, and of course, it's very important depending upon the use case. You have to make sure that you have the right resolution of the measurement tool. If your use case is such that you don't really care, let's say milliamp and all is okay with you, maybe that's good enough. But if there's a use case where you really need to optimize every little ounce of the battery, then you have to go down to that particular level and do the right measurements, right? So you can do the measurement while you are doing the, in fact, coding, that you have to use the right power measurement tools, which could be power meters, which can give you a lot more information. So depending upon, again, the use case, if I'm using a battery sensor where a battery has to last for 3 years, I have to go down to the microamp level. If there's something which I can recharge on a daily basis, maybe a crude estimation is also good enough, right? And if it's something which is non-battery operated, wall powered, in that case, maybe even simple data sheet is okay. So depending upon where you are, you have to pick up the appropriate information and the appropriate tools to enable you to do the design.
So I was looking on the website, and I also saw some news recently from Silicon Labs regarding the SIWX917, which is an ultra-low power Wi-Fi 6 transceiver, and it's also got a Bluetooth integrated that in as well. So can you tell us a little bit more about that particular device and explain sort of how it supports those low power IoT applications?
Sure, absolutely. So our previous generation product, as I mentioned earlier, was RS9116, which was a Wi-Fi 4 product, which had Wi-Fi 4, Bluetooth Classic, and BLE. And that also was an ultra low power device. So what we did with the 917 was took it one step further. So in 917, we support Wi-Fi 6 and we support BLE. And this is the lowest power Wi-Fi 6 in the industry today. Okay, and we are carrying over whatever we did in 9116, which was more of a system level power optimization, which enables us to do optimization, in fact, at the microamp level, where we can wake up very fast, we can transmit the data, go back into sleep very fast. So that whole infrastructure was already present in 9116. We are carrying that over here. In addition to that, we have also added all the Wi-Fi 6 power save mechanisms, right? Of course, TWT is there, OFDMA is there. Because of that, we can reduce overall the power consumption of the system a lot more. So that's something which is very unique in this particular device. It has an integrated Wi-Fi 6 capability. Of course, it supports Wi-Fi 4 and the earlier technologies as well. It also has BLE, which is integrated inside it. It also has a complete Cortex M4, and which is meant for customer applications. In addition to the Cortex M4, we also have another microcontroller, which is a network processor, which is running all the stacks. So when you're talking about an IoT device, really you need all the wireless stacks, which is Wi-Fi stack, BLE stack, the networking stacks have to be there, the cloud connectivity has to be there. So all of that mechanism is already there. It's running on a different processor, which is a network processor. In addition to that, we have a Cortex M4, which is running in RTOS, and the customer can use the Cortex M4 for writing the complete application as well. So it is a completely integrated device meant for IoT designers, including a complete network processor, as well as a Cortex M4 and Wi-Fi and BLE connectivity, providing the lowest power consumption in the industry.
So one question I have quickly as well is Embedded World's coming up, isn't it? We're just a few weeks away. Will visitors to Embedded World be able to see this in action?
Oh yes, absolutely. So not just this, we have a few other major things also beyond this. Of course, 917 has Wi-Fi and BLE capability, and of course, Matter is coming up pretty strong, right? So people are talking about Matter. So we are going to demonstrate Matter running on 917. Okay, so Matter can run on Wi-Fi, Matter can run on Thread. So we are going to demonstrate the Wi-Fi portion using 917, and we have another device called BG24, In fact, an MG24, these are the two other devices. So we are planning to show Matter running on that as well. So that's an important part. Absolutely, it's a complete Matter solution, which includes Matter over Thread, Matter over Wi-Fi. We also have a Matter demo, which is for bridging solutions from Zigbee, Z-Wave to Matter, because what is happening in a home environment, you have Zigbee devices, you have Z-Wave devices, which are there, traditional devices, and there are a lot more devices which are going to come, and they need to bridge onto the Matter network as well. So we have also created a bridging solution, which we are going to demonstrate as well. In addition to that, we are also announcing a couple of things there. So we are announcing a new product, which is, in fact, the BG27 product, which is a very low power Bluetooth device, which is going to be demonstrated there as well. So that's an important one. In addition to that, we are also going to show a demonstration of high accuracy distance measurement using Bluetooth technology. So this is a new technology which has been promoted by BTSEC. We had demonstrated that at CES, and we are going to demonstrate that further at Embedded World as well. And then in addition to that, the final thing that we're going to do at Embedded World is also a major launch around an MCU. So we have Silicon Labs is traditionally pretty big on low power MCUs. So we have 32-bit MCUs, 8-bit MCUs as well. Right? So we are planning to make an announcement around the MCUs as well, where we are improving the support for 8-bit MCUs, and we are also going to show a portfolio for a 32-bit MCU family as well.
Fantastic. It sounds very exciting. I'm looking forward to dropping by the stand to have a chat and see some of this technology in action in March. That's the 14th to the 16th of March in Nuremberg, Germany, for those who've not attended before or would like to join. So we're rapidly running to the end of our time, unfortunately, but what I wanted to finish with was one last question on that wireless SoC technology device. How does it look at Silicon Labs when we want to start getting into sort of hardware and software development? What sort of tools and development environment do you have in place, and how does it look with the software stacks?
Sure. So if you look at all the products from Silicon Labs, right, we have a few major pillars that we use across all our products. One of the pillars is, of course, power that we talked about, right? So all our devices that we're doing, they're all low power devices. We have all the techniques for power reduction for each one of the devices. Second pillar that we have is really all our security. And every device that we have, we are adding to the security as well. The third pillar that we have recently started adding is ML. And that's one of the things which I forgot to mention in 917 earlier. We have a complete ML accelerator, which is built into 917 as well. So it enables people to do things like keyword spotting. So you can have some data processing there as well, to do some small machine learning devices on the edge. So that's the third pillar that we have. Now, the fourth pillar that we have is the complete software development environment, which is consistent across all the products that we have as well. So that is something that we have done across all the products. We have this thing. We have a solution called Simplicity Studio. Users get a very unified experience, whether they are designing with BLE or Zigbee or Z-Wave or Wi-Fi. So the complete solution is available as part of the Simplicity Studio IDE, which is offered by Silicon Labs. So this is something which is very unique, and this is one area where we put in a lot of effort, because the user experience is important. And if the user experience is not consistent and users are not able to develop the solution easily using our solutions, then certainly the adoption level is going to be low. So this is something that we have invested significantly in, and we'll continue making more and more investments to ensure proper UX and DX for the end designers.
Fantastic. Well, it's all sounds like a very rounded solution, and looking forward to seeing you all there at Embedded World to examine it in a bit more detail. I think one of the other interesting things that I found on the website as I was looking around is this white paper here as well, for those who'd like to dig into the details a bit further. It's called The Future of Wi-Fi in Low Power IoT Devices, and it gives a great overview of those mechanisms within the specification that supports these power saving capabilities within the Wi-Fi protocol. And I think it's very helpful to understand how you engage them and what they enable. And we're going to add the link to that white paper in the description below the YouTube video, and elsewhere where we'll be posting this as well. So Dheeraj, it's lovely to talk to you again. It's really nice to catch up. I'm really grateful that you've taken the time to talk to us today and give us all your insights as you do so beautifully. Have a great trip. I know you're away from home at the minute, and we look forward to catching up with you again soon.
Thanks a lot, Stuart. It was great talking to you, and certainly I always love our conversations. I'm looking forward to seeing you at Embedded World, where we can demonstrate all of these technologies. And one more thing I do want to leave out is really we have a whole series which is going on, a Tech Talk series, where we are talking about low power consumption as well. So we have a Wi-Fi series, we have a BLE series, we have a Matter series, and we have an LP-WAN series. Please go and take a look at the Silicon Labs website, and you can register for the series as well, where you can get more information on how to optimize power for various kinds of devices.
Sounds like a great opportunity to learn more. Super. Thanks ever so much.